When it comes to application of rate of change, okay, the first thing you have to remember that Mr. Ivan is going to tell you is the y can change to area, can change to volume. The x can change to height, can change to radius. Okay, so that's the first thing you have to remember. The second thing is, if when there are two variables on the right side, you cannot differentiate. Okay, you cannot differentiate. If you have an equation with both r and h, you cannot differentiate. You got to make r or h the subject first, the one that you usually want to remove. Sometimes the question will give you information. If not, you have to use similar triangle, especially when there's cone. Okay, then so I wrote down here two simple ways of forming the connected rate of change that it involves area and volume. So dA dt is equals to dA dr multiplied by dr dt. So just make sure that this side and this one can cancel and they are mathematically equal. Or you know dv dt equals to dv dr multiplied by dr dt. This one and this one can cancel, and then you know they are mathematically equal. Okay, dA dt also means this is the rate of change of area. This is the rate of change of volume. Okay, dr dt, rate of change of the radius. Okay, or dh dt, rate of change of height. Now, when you have an equation a equals to pi r square, when we differentiate, it will become dA dr. The a is the y, the r is the x. Differentiate the r, power bring down. That's why it became 2 pi r. If the volume is 1/3 pi r square h, which is a cone, you cannot differentiate unless they tell you that there's a fixed height. But if you have r and h as variables, you cannot differentiate. So you have to use information from the question, sometimes similar triangle, sometimes the question may tell you, the sum of the height and the radius is 10. Then, if we want to remove h, we make h the subject. H plus r equals to 10, h equals to r minus 10. Okay, then now we replace this h. Can you see this h here? Pi r square h, right? Yeah, and then this is the h. V equals to 1/3 pi r square h. When we differentiate this equation, okay, remember this is the product rule. This guy is my u, and then this guy is my v. The 1/3 pi can just put on the outside. Okay, then remember to use your u dv dx plus v du dx to do your product rule. Okay, so this is how you do an application of rate of change. So I'll go through one very long example together with you. Okay, so the above diagram, okay, show a trough or a drain of 3 meters. So the length is 3 meters here with 1 meter deep, okay, and ABCD as the horizontal. It is an isosceles triangle with a base of 2, okay, 2. And the vertex pointed downwards. The empty trough is filled with water. When you look at this, the units will tell you what is this talking about. This is because it is volume, right? Meter cube is volume. So this is called the dV over dt because it has got to do with time. It's 0.03 meter cube per second. Now, water keep coming in. So what keeps changing? The height of the water keeps changing. There's also another thing that keeps on changing, but it's not mentioned here, is if you draw a diagram like this, okay, and then this is the water that keeps on changing. Here is the height, and here is 1, okay, here is 2. All right, now if I want to find the volume of water, which is, we need to find the cross-section area of this. To find the cross-section area of this, okay, you need the base. You don't know what is the base, right? So we can name the base as x, okay, or whichever you wanted. Okay, if you don't mention this, you will not be able to find. Okay, you don't need to use maybe you can use Pythagoras theorem to find the size, but that would be a longer way. Okay, now you can see very obvious there's a similar triangle, and Mr. Ivan always says small over big, x over 2 is equals to h over 1, or small over big equals to small over big. Now, because the volume of the water here, the equation is here, show that it's equals to 3h squared meter cube. I don't have a x. X is something I added in, so I make x a subject. X is equals to 2h. Now that I have this, Okay, because if I want to find the volume of the water inside is half times the base is x times the height which is h, okay, times the length which is 3. This is the cross section area times the length. I realize that I will have 3 over 2 xh over here. I have two variables on the right side. I cannot differentiate. That's why I must replace the x by 2h, which is what I found using the similar triangle over here. Okay, hence the volume is equals to this and this cancel 3h square meter cube. And the first part is done. Okay, so next, I know that the second part is talking about rate of change. How do I know? Because the question asks, what is the rate at which the water level is rising? Water level is h. The question is asking for what is dh over dt after running for 25 seconds. And that is the clue that they gave you. Just now, if you watch the first part of the video, you realize that when you do rate of change, you need an x. In this case, you need a h because x represents h on the right side. We need the h, but we don't know what is a h. So after 25 seconds, the volume of water is equals to 25 times the rate, 0.03. And that is equals to 0.75 meter cube. Okay, so I know that from the rate and the time I find the volume. This is also one skill you have to know, which means that 3h square is equals to 0.75. H square is equals to 0.25 divided by 3. H is equals to 0.5 or negative 0.5 when you square root 0.25. In this case, this is rejected because the height need to be greater than 0. So now I have that height is equals to 0.5. I can do my rate of change already. Okay, I go back to here. I got volume, which means my dV over dH. Because the right side is H, the left side is V. When I differentiate, the V is the Y. Okay, equals to, I differentiate this, 6 power bring down 2 times 3, 6H. Okay, and I sub in when H is equals to 0.5, my dV over dH is equals to 6 times 0.5, which is equals to 3. Now I can form my connected rate of change formula, which is, okay, dy dt is equals to dy dx multiplied by dx dt. This is the original one. So if I want to transform it in terms of volume, dv over dt, because Mr. Ivan says that y can change to volume, is equals to dv over dh, which is what you have over here, multiply by, in order to make it mathematically equal, this has to be dh over dt. Okay, dv over dt, do you have? Yes, first part of the question already tell you this is 0.03 equals to dv dh, you already found 3 over here, times dh over dt. So if you want to find out what is dh over dt, all you need to do is to divide over. So dh over dt is equals to 0.03 divided by 3, and hence you get 0.01. Remember to write the units. The height is in meter, the time is in seconds. So this is how you do a application of rate of change question involving similar triangle, involving using the rate to find the volume, to find the h, okay, involving introducing variables on your own.